Welcome to my presentation. In this presentation, let us try to use the properties of inverse to find to solve a simple example problem. Let's say we have an example of this type, and in this example, the matrix A has the following elements: 1, 2, 3, and 4. And in this case, we want to find A to the power of -2, like that. Okay, so in here the way to do that is as follows. We will write that as step number 1. A to the power of -2 we can write as A to the power of 2, the whole thing raised to the power of -1, isn't it? So we can find A to the power of 2. We can find A to the power of 2 as A times A. Since A is a matrix given to us, we can find the product of that, and then once we find the product, then we can go back and then find the inverse from there. Once we have that matrix, we'll find the inverse of that using Gauss-Jordan elimination method. Okay, so let's try that. So A to the power of 2 is going to be A times A, and then A matrix is 1, 2, 3, 4, and then when we take that and then multiply it to the same matrix again, 1, 2, 3, 4, the result is going to be as follows: 1 times 2 plus 2 times 3, that is going to be 1 times, let me write that here, 1 times 1 plus 2 times 3, that will be the first location of the product matrix. 1 times 2 plus 2 times 4 will be the second location, and then 3 times 1 plus 4 times 3, that will be the second row, first column location, and then we have 3 times 2 plus 4 times 4, that will be the second row, second column location. So we have 1 plus 6, then 2 plus 8, and then 3 plus 12, and then 6 plus 16. So when we simplify this, this is what we're going to have: 7, 10, 15, and 22. Okay, so A to the power of 2 is that. And now we want to find the value, we want to find the inverse of that. So we want to find A to the power of 2 and then to the power of -1. We're going to follow this process here as we talked about in our earlier example problems. We're going to take the given matrix and then partition it with the identity matrix, and the given matrix for us is 7, 10, 15, and 22. And then on the right hand side of this partition, we're going to have the identity matrix. Since we have a 2 by 2 matrix in A, the identity matrix will be a 2 by 2 matrix as well, and the elements of that would be 1, 0, 0, 1, like that. And therefore we want to be able to when we've transformed this matrix, I'm going to write the procedure here just in dotted line, and then we'll come back and then do all the steps. When we perform this operation, and this procedure is called the Gauss-Jordan elimination method, and when we perform this, the left hand side, since this is A, this is matrix A, and this is the identity matrix I, when we perform the row operations and when we use the Gauss-Jordan method, this matrix is going to be transformed as follows. We're going to have 1, 0, 0, 1 on the left hand side of the partition, and then we're going to have numbers on the right hand side of the partition, like that. So therefore this is going to be our identity matrix, and this is going to be our inverse matrix. So that is what we want to achieve, and we will try that try to follow that procedure and then achieve that for this example problem. So let's get started. We want to make this location as equal to 1, and to do that we're going to write this one out as follows. The new R1 is going to be equal to minus 2R1 plus R2. If we do that, we should be able to get a 1 there, and then therefore negative 2 times 7 is negative 14. Negative 14 plus 15 is positive 1. Negative 2 times 10 is negative 20. Negative 20 plus 22 is positive 2. Then we'll partition that. And then we have negative 2 times 1 is negative 2 plus 0 will be negative 2. Negative 2 times 0 will be 0 plus 1 will be positive 1. And then the second row comes down as is 15, 22, 0, and 1. Okay? Then we want to make this location as equal to 0. As we always do, we want to draw a line along the major diagonal to see where we are on the finish line. We have 1 at the first row, first column. We want to make those the location second row, first column, which is 15. We want to make that as 0. So we'll perform the row operations to try to get that, to try to achieve that. So to do that, to get that, we're going to perform the row operations like this. The new R2 is going to be equal to negative 15 R1 plus R2. When we do that, we should be able to make that location as equal to 0. Negative 15 times 1 is negative 15 plus 15 will be equal to 0. And then negative 15 times 2 is negative 30. Negative 30 plus 22 is negative 8. And then we'll put the partition there. And then negative 15 times negative 2 will be positive 30 plus 0 will be 30. And then negative 15 times 1 is negative 15 plus 1 will be negative 14. And the first row elements we have 1, 2, negative 2, and 1. Okay, so let's draw this line one more time. We wanted a 0 there along the major diagonal. We wanted a 0 below the major diagonal. We want to make this location as equal to 1. And therefore, to achieve that, we're going to perform this row operation. So we're going to take the new R2 is going to be equal to existing R2 divided by negative 8. By dividing by negative 8, we should be able to achieve that. So 0 divided by negative 8 is 0. Negative 8 divided by negative 8 is 1. We'll put the partition here. And then 30 divided by negative 8, we can simplify that as negative 15 over 4. And then negative 14 divided by negative 8, we can simplify that to 7 over 4, like that. And therefore we have 1, 2, negative 2, and 1 in the first row. We'll bring that down as is. And therefore now, if we were to draw a line along the major diagonal, we see that we have 1s along the major diagonal, we have 0s below the major diagonal. We want to make this location 0. And to achieve that, we're going to perform this following operation. We're going to follow this the following row operation. The new R1 is going to be equal to R1 minus 2R2. R1 minus 2R2. When we do that, it's going to be as follows. 1 minus 2 times 0 will be 1. 2 minus 2 times 1 will be 0. We'll put the partition there. And then on the right hand side of the partition, we have negative 2 minus 2 times negative 15 over 4. And when we simplify that, that's going to come down to negative 15 divided by 4, like that. And then 1 minus 2 times 7 over 4. When we simplify that, that is going to come simplify to 7 over 4, like that. And in these numbers should be 11 over 2. There should be 11 over 2 on this location, and then there should be negative 5 over 2. And the way to achieve that is negative 2 minus 2 times negative 15 over 4. when we simplify those fractions, we get 11 over 2, and when we simplify 1 minus 2 times 7 over 4, we get negative 5 over 2. This is a 2. And in the second row, we have the elements as 0, 1, negative 15 over 4, and then 7 over 4, like that. Okay, now we'll go some more and see how we can achieve that. Now if you look at this, we have along the major diagonal, we have ones along, and above the major diagonal and below the major diagonal we have zeros. So therefore this is our identity matrix, and we have achieved the inverse matrix. That is our inverse matrix. As you can see, the inverse matrix, let me write here, the inverse of the given matrix is, since A was a to the power of 2 for us, and then the inverse of that, we have achieved that here, which is 11 over 2, negative 5 over 2, negative 15 over 4, and then 7 over 4. This is our inverse of the matrix. Okay, this is how we should be able to find the inverse of the matrix using the Gauss-Jordan elimination method. In my next presentation, we shall look at some more examples related to properties of inverse and how to solve some simple example problems.